Part E says use the results in part C to determine the gradient and the y-intercept of the equation of the line of best fit. And this is called linear regression. To get assistance for such a question, we got to go to week 8. Assistance is in week 8 for linear regression. So let's go to week 8. This is week 7. Linear regression. As it says, linear regression in a nutshell is concerned with the modeling of a linear equation that can be used to predict or forecast future values. This course is concerned primarily with two methods in which this can be done: least squares and geometrically via the scatter plot. So as you can see, to apply least squares, it says the equation of a straight line has a standard form y is equal to mx plus c, where x and y are the related variables. X is the independent variable, y is the dependent variable, m is the gradient of the line, and c is the y-intercept. Now, the steps to obtain the linear equation via least squares: first, you calculate the gradient, m, using the formula. As you can see, the numerator of this formula is exactly the same as the product moment, and this is actually a. And the denominator now is the second part, where you have 3 subtract 4, the third number subtract the fourth number, and we call this b. So therefore now, the formula for the gradient has simply been simplified to a over b. We have already calculated a, we have already calculated b. Now the y-intercept now, this is the formula for the y-intercept. The sum of y minus m times the sum of x over n. It says to place the values of m and c in their respective position, and then you get the equation of the line. So let's find the gradient, and then we're going to find the y-intercept. So we can do that here. So m now is equal to a over b. Simple as that. So m is 1.077 or 1.08 as the gradient. So we are modeling a linear equation. So we can use that linear equation to do some forecasting. C now is equal to, as the formula says, open bracket, the sum of y, subtract m, we just calculated m, times the sum of x divided by, close bracket, divided by n, which is 7. So C is 39.85. And now we can write out the equation now. Y is equal to mx plus c. We can do that right there. Y, or score, because score is y, 1.08. We can round off to 2 decimal places, times hours, plus the y-intercept, 49.85. And later I will copy this and paste this in the whiteboard. So this equation can be used to do some forecasting. Also, you can confirm that equation using an online calculator. So you can type in Google product moment coefficient calculator with least linear or linear regression or linear equation, okay, or linear model. Model is another word for equation. Okay, I think we can use Pearson correlation coefficient calculator. Take me to calculator. This one, we used this one a while ago. It does not have the least squares. Let's use another one. Or can just type linear regression calculator. Linear regression calculator. There it is. You can click on this one. It's very same one we're using there, but this one will give you the linear regression calculator. You can copy this link. Whiteboard, so that you can have access to it. And here's the whiteboard there. Okay, let's pick this up later. So let's go back to the calculator, right? And simply copy X value and the Y value separately. And we can use this now to prove our answer for the linear model. You can use this model to forecast. Here you can type your estimates, okay, and you can see where it says calculate the regression equation. That's another way to say it. As you can see, there's the scatter plot, and here is the equation. 1.08x plus 49.85, and this proves our answer that we have gotten. And it gives us the scatter plot, it gives us the line, and we can use that line to predict certain values for hours and score. So that takes care of this question. Here it is.